Hey guys, it's Andrew once again with Darkhorse Motor Company here with John Dahmer.
Hey.
So we talked a little bit about our rods, our crank pin bearing setups, and now we are going to chat a little bit about our flywheel halves. We have two sprocket shaft and a pinion shaft flywheel half in front of us here. John, why don't you go ahead and tell us a little bit about what we do to make these individual for our customers.
Yeah, well, I mean, as you know, these are a couple of different applications as far as our man-of-war crankshafts go. We really want to tailor it to the specific application, right? So we're pretty proud of these, of course. These are what essentially is in all the King of the Baggers stuff. This exact flywheel won the national championship last year with Vance and Hines.
Sure did.
And Hayden Gillum, and we're all pretty proud of that, right? That's a company as a whole that we've worked together with. Terry Vance is a good friend of mine, and really we worked hard to design this specifically to work in that application.
Right.
Now, what works in those bikes doesn't necessarily work in the street bikes, as you well know.
You
right?
know, that is great that you say that, because I do get a lot of questions about lightening the flywheel assemblies. Is it something that your average everyday rider wants to do? You know, what if a guy does a lot of touring? Do we want to lighten his flywheels?
Well, and of course, the OE flywheel is lighter than actually our man-of-war.
Correct.
In its base form.
Right.
These flywheels are actually lighter than OE flywheels.
Mm-hmm.
Per Moto America rules. We are able to do it. I mean, when we do the machining to this, it's very specific because we want to be able to balance this flywheel yet.
Right.
Even in this form, it is not truly balanced.
Right.
We're going to balance each given flywheel. Of course, for the pin rod bearing configuration, along with piston weights, compression, all those things that we put into our balance factor when we're doing that equation. RPMs.
Right.
The King of the Baggers bikes rev to 7,000 RPM. That's not something that your typical street rider, of course, is going to do.
Right.
As you well know, the heavier the flywheel, the smoother the ride is. When you get into some of this very light stuff, the engine pulse, of course, is going through the chassis.
Right, you can feel it a lot more.
You can feel it, and of course, when you get too light, you have very, it's very noticeable, right?
Is there a too light?
I think in a touring bike, you certainly can end up too light, because then, of course, I think you've ridden one of our shop bikes, right? It's like a light switch,
right?
And you're on off, and not only on throttle where it's like a light switch, but off throttle, and you get compression braking, and it falls just flat on its face. So then you're constantly modulating the throttle to try to make it a enjoyable
ride,
enjoyable touring bike, and I don't think I don't want that, right? That's not me. When you're trying to go to Sturgis 1,000 miles and you're sitting there all the time trying to modulate it.
Is there a balance to where you can maybe take a little bit of weight out and have a little bit of the best of both worlds?
I mean, this is our street version, of course, of our man-of-war.
Yep.
Lightened very strategically. This one isn't balanced yet, but of course, that one I believe is pretty close to right on the money. I think the OE crankshaft in its natural form is a pretty nice piece, balanced properly. I mean, as you know, we take a lot of the counterbalancers out.
Right.
A properly balanced crankshaft on a touring bike, on a rubber-mounted bike, doesn't necessarily need the counterbalancers. They designed it so that it was smooth at idle, right? And it works very well. Counterbalancers work amazing at idle, right? Turn it into a Goldwing, why not?
Exactly. So with the process that we do with lightening these things, now, is there any reason why we don't go all the way through? You know, I've seen some other crankshafts out there, and I think we did at one point have one that went all the way through. Now, is there a reason why we switched that?
Well, windage. Windage was the primary factor, and you know, you can see that really there's a pretty big shelf in this crankshaft. Actually, some factory engineers felt that it created too much windage within the crankcase. which can cause some other problems.
Okay.
So we can get to that at a different date.
Right.
But this by design reduces windage within the crankcase, some compartment. So there's actually, I don't know if you can see this, but there's an angle cut on this specifically to reduce windage. But then, of course, it's designed also so that we can balance it properly. You know, we never want to be impacting and drilling holes right above the crank pin, right?
Correct.
We've talked about that a number of times. We always stay away from that because the integrity above the crank pin is very important, right? When these flywheels are going at 7,000 RPM, it's natural that they're going to want to move, right? And so we try to keep that area and the integrity there as much as possible. But we're able to cut out the windows to get the most weight out. And then, of course, you know, on a lot of race bike, we know what the piston weight is. We know what our balance factor is, and we design our CNC programs to lighten these flywheels specific to that. So we never have to drill above the crank pin. We're always correcting on the counterbalance side of the crankshaft, and that keeps our guys in balance, very efficient. They're not drilling 1,000 holes. And that's all by design. That's all engineered by our engineering department, and works very well.
Very good. Well, this is interesting. You know, I've always thought it was really cool that we can lighten the flywheels like this, and it really makes a big difference in a performance application. And you know, a lot of guys that like to ride on twisty roads like them lightened as well, because the engine brakes a lot heavier and it accelerates a lot faster. So that's really all I got today.
Right on. Thank you very much.
Thanks, guys.